Okay, in this video we will be talking about right triangles. So we have this triangle here. The sides are labeled A, B, C. Now this little square in here means that that's an angle and it's 90 degrees. See, each angle has a measurement and a square corner means it's 90 degrees. 90 degrees. Put a 90 there. And then all three sides have to add up to 180 degrees, but we're not concerned about that today. What we're concerned with is finding what all the sides measure out to. And if you have a 90-degree triangle, it's not just any triangle, but it has to be a right triangle. A right triangle is called 90 degrees. Okay, it's called a right triangle. That means you have an angle in there that is 90 degrees. Now, there's a theorem that relates all three of the sides. Now, one thing though, this C right here, the ABC, the C always has to be opposite from the 90-degree angle. So here's your 90, and all the way across, the side that's across from 90 degrees is your C. That's important because that's the longest side. It's known as the hypotenuse. Okay, here's how you spell that: Hyptonuse. Hypton, hypotenuse. Okay, I think that's spelled right. Hypotenuse. Okay, now A and B can be mixed around, but C always has to be opposite the right angle. So there's an equation that relates the sides. It's A to the second plus B to the second equals C to the second. Okay, A squared plus B squared equals C squared. Now, in these problems, I'm going to draw the right triangle. You don't really have to if you don't feel that's necessary, but just so you can see. So this is my 90 degrees, and across from that is my C. Now I can put AB or BA. It doesn't really matter, but these are, the C is called the hypotenuse, and A and B are called the legs. So leg, leg. Okay, the legs can be interchanged, but the hypotenuse has to be here. Okay, so I know A and I know C in this first problem, but it's on me to find B. It says find the unknown lengths of a right triangle. They're going to tell us two of the lengths, and we have to use the Pythagorean Theorem, the A squared plus B squared equals C squared, to find the third side. So A squared plus B squared equals C squared. So A I know is 3 to the second power, and then B is what we don't know, so we keep that as a variable, B second power. And then C we know is 5 to the second. Now, we need to get rid of the second powers where it's possible. See, 3 to the second means 3 times itself. 3 times 3, and that's 9. Okay? So we replace 3 to the second with 9. And then B, we don't know the B value, so I keep that B to the second. And then 5 to the second, that's 5 times 5, that equals 25. Okay? Now you solve for B. Now you're going to use linear properties because B to the second power is all you have. But there's technically two answers to this equation. Okay, so you can go B equals, but you don't have to do this because we're only concerned about the positive answer. Okay, so here's my B to the second. So it's the issue of the 9 and the 25. That's the problem. Okay, so the 9 and the 25 are on opposite sides, so we need to subtract the 9 from the side of the B to the second and then put it over there. So if these constant values, the known values, are on opposite sides, you're going to take out the smaller one, okay, with subtraction. And it'll always be subtraction. You won't have to add because they're always positive. So B to the second equals 16. Now you cancel out a second power with a square root. You should know that by now. And then positive or negative, and the square root of 16, okay, is 4. Okay, so this is not an irrational square root. We don't have to put IRR and start dividing. Okay, we just put 4. So B is equal to 4. Don't worry about the negative. That's why you're just worried about the positive. By the way, when you find these three, C always should be longer than the other two. Okay, the C value should be. Okay. All right, next one. A squared plus, again, here's the right triangle. Okay, so this is C, the hypotenuse, and the legs are A and B, or B and A. It doesn't really matter. So A squared plus B squared equals C squared. Okay, so the A is what we don't know. Okay, I know B, I know C, I don't know A. So A to the second. And then B is 3, so 3, don't forget it's 3 to the second though, or you already messed it up. Then C, that's 7, 7 to the second. Now we have to evaluate the exponents where it's possible. So I can't evaluate A to the second. 3 to the second, that's 3 times 3, and that's 9. Okay. Then 7 to the second, 7 times 7, that's 49. You don't take 7 times 2, you take the base 7 times itself. Okay, so I need to solve for A. Again, we have A to the second only, so it's linear properties. Okay, so I have to get the A second by itself and get rid of this 9. Okay, so minus 9, so that's 40. So now I find the square root of 40. And I'm not even going to put the positive and negative because when I'm finding the length of something, I don't use the negative answer. But here's the problem with 40. If I find the 40 doesn't really have a rational square root. Okay, it's irrational. So in this video, if that square root is irrational, okay, see 16 was a perfect square, it was 4. Okay, but 40, I'm not seeing that. So I put the division sign, I put the IRR label. Okay, see I didn't here because 16 is a perfect square. 40 is not. So irrational, IRR. So divide by. And then I go 40 divided by. Okay, and then I start going. Divided by 36 decimal. 25 decimal. 40 is not divisible by 16. If you get a decimal, it's not divisible. You keep moving up your perfect square list. 4. So it'd be 4 and 10, okay? So remember, don't put 4 and 2, you put 4 and 10. Now I replace the square root of 4 with its integer value of 2, okay? So 2 square root 10, and that's your answer for A. So A is 2 square root 10. Remember, C should be the longest side, and it is. So 7's longer than 3. It's longer than 2 square root 10, because if you go 2 second square root and put 10 in, yeah, 7 is longer than 6.32455532. Okay, I mean 7's larger than 6. Okay, so yeah. Okay, A is 5, C is 6. I'm supposed to find C. Now this one works out a little bit differently as far as the actual equation. So you have A, B, and C. So A squared plus B squared equals C squared. So A is 5 to the second. B, that's 6, 6 to the second. And C we don't know. Okay, so C is what I have as a variable. Now, get rid of the second powers where possible. So 5 times 5 is 25. So we replace this with 25. 6 to the second, that's 36. And then C to the second would remain a variable. Now, you're using linear properties still, but the C to the second's already by itself. So what we come and do, we don't subtract. We come over here and add these two together. They're on the same side, they're like terms, so it's 61. Now I get rid of the second power with a square root. Now 61 does not appear to me like it is a perfect square, so that's IRR. So you put a division sign, and then square root times square root in parentheses off to the side. You don't have to put parentheses, just that's how you're going to do that. Okay. So C's right there. Okay. So 61 divided by 49, nope. 36, nope. So I do want all irrational square roots simplified, not just written as decimals, or you're getting a 0 for the assignment. Decimal, decimal, decimal. So I guess that leaves us at 1. Okay, so 1 and 61. So I was able to divide by 1, I got 61. Now the square root of 1 we know is 1, but having a 1 coefficient means we don't have a coefficient then, and we just leave the square root of 61. Okay, so C equals the square root of 61. Make sure the square root's there, you don't just put 61. Okay. Now you're like, how do I know if C is the longest side? Well, you can square root 61 on your calculator, 7.81, and that's bigger than 6. It's bigger than 5, so I know I'm probably right on the money. Okay, next one. A equals 5, B equals 5, C equals 10. And we have to find A, obviously. So remember, this is C, that's the hypotenuse, and the legs are A and B. So A squared plus B squared equals C squared. So A, I don't know A, so that stays A to the second. B, we know is 5, 5 to the second. And then C, we know is 10, 10 to the second. So 5 to the second, we take 5 times 5, and then 10 to the second, we take 10 times 10. So 25, and that's 100, okay? So A stays in variable form, then 25, then 100. Now, you're using linear properties, so just make a line on the A second side. There's a 25 over there we have to take out, so subtract 25, and 100 minus 25 is 75. A squared equals 75. Now, find the square root of 75. A equals right in front of that. You don't need to put the positive and negative because we know we're just going to use a positive. Now, 75 is not a perfect square, okay? So you have to label it IRR, irrational, and then put the division sign. And I'm just going to make a parentheses with square root times square root, okay? Little organization works. So 75 divided by 64 is a decimal. 49 is a decimal. Divided by 36 a decimal. 25 and 3 is what I'm using. So I'm going to put 25 and 3. And of course the square root of 25 turns into 5. Okay. So A is equal to 5, coefficient 5 times the square root of 3. So A is 5, square root 3. C should be longer. Well, 10's longer than 5. Is it longer than 5 square root of 3? Yeah, it is. 8.66, 10's bigger. Okay. Next one. Okay. Okay, this is C, this is A, this is B. Okay, so we're finding C here. Now, A and B can be the same. So if the legs are the same, that's called an isosceles triangle. Okay, should have learned that term in middle school. But you don't really need to know that it's that, but yeah, C second. So A is replaced with 8, and B is replaced with 8, both to the second power, and then C to the second. So 8 to the second is 8 times 8, and that's 64. And then this other one's going to be the same thing. And then we have C to the second. Now we use linear properties to solve it, okay, LP. So C to the second's by itself. We don't have to take out anything. So what we do before we do the square root, though, we need to go over here and add those together. So add those, you get 128. So square root that. So equals C. Now, is 128 a perfect square? No, it's not. It would be here if it was. Okay, so put IRR, and then the division sign, and just come over here on the other side, make your parentheses. Square root times square root. So 128 divided by. I need to start at 121. Nope. 100. Nope. 81. Whoops. Nope. And then 64. Okay, bingo. So we put 64 and 2. Okay, so we're basically rewriting that as 64 times 2, because the square root of 64 is equal to 8. So it'd be 8 times the square root of 2. Okay, and that's your value for C. Now 8 multiplied by the square root of 2 is going to be bigger than the 8's. Okay. Yep. Okay, A equals 8, B equals 12. We got to find C. So A squared plus B squared equals C squared. Okay, so A is 8, B is 12, and C is unknown. Okay, so it's kind of going to be like the last one. So 8 times 8, 64. And 12 to the second, that's 12 times itself, that's 144. then c to the second. Now we apply linear properties. C second's already by itself though. Okay, so we just go over here and add the terms. Those go together. And 64 plus 144, I think it's 208. Yes, it is. 208. Okay, square root. So the square root of 208, well, it's not a perfect square, so it's irrational. And square root times square root off to the side. Okay, then you start dividing. Okay, we're solving for c. So 208. Okay, you divide by 196 first. Nope. By 169. Nope. 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 Be patient. Nope. 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 Doesn't matter if the decimal ends, it can't be a, okay, we got 16 and 13. So the square root of 16 is equal to 4, so we replace that with 4, so it's 4 times the square root of 13. 4 square root of 13. Okay. Now remember, we said C should be the longest side. Well, let's plug in that 4 square root of 13 just like that. I don't want that as the answer. 14.42. Well, that's bigger than 8 and it's bigger than 12, so that's got to be the answer. It might be irrational, but it's still larger than the other two sides. Okay, A equals, that's a 9 there, and C equals 41, so you have to find B. Okay, so A squared plus B squared. As you know, I've quit drawing the triangles. I don't really need to do that by now. So 9 to the second, that's a 9, okay. B, what we don't know, so B to the second, and C is 41, 41 to the second. So we will be taking 9 times 9. That's not still an A, that's a 9. My A's kind of look like 9s, but 9 times 9 is 81. $1,681. Okay, so 1,681. So we have to apply linear properties. Now B second, here's the equals. B second's not by itself. We have to take out the 81 by subtracting. So this minus this is 1,600. Now I know you're going to apply the square root. Now I know what you're thinking. How do I know if that's irrational when my sheet doesn't even go to 1,600? Well, you take your darn calculator, find the square root of 1,600, and it is not irrational, okay? So I don't do that IRR crap and divide, okay? You just put that as 40. It's a perfect square because 40 times 40 is 1,600, okay? When I square rooted, I got an integer. I didn't get that long decimal. So therefore it's not IRR, and we just bring the 40 down here. Okay, so B equals 40, and C is the longest side. B is close to being that long, but as long as C is the longest, it's correct. Okay, now a couple things I need to show you. Number 4, this is not 1.2, it's 12. Okay, 12. There will be no decimals on this whole assignment. Okay, all right, now please remember, if it's IRR, meaning if the square root is some crazy decimal, that's when you put the IRR label and divide. If the square root is a whole number, then you don't do that, you just write the whole number equals.